Hello everyone, in this video we will see about the page replacement algorithm. Why the page should be replaced is we all know about the concept of swapping. Main memory is a small memory but this can be directly accessed by the CPU. But our programs are very large. So in order to make comfortable to run all the programs in our system or the big program in a system, we use the concept of page replacement. The page is replaced between the main memory and the secondary memory. We call this as a swapping operation. In order to do this swapping operation, there should be some algorithm. So they are termed as page replacement algorithm. So here, what is page replacement algorithm is, you can see there are many algorithms, and let us see one by one. And definition for page replacement is find some page in memory but really not in use. Page it out. That means if a current page is not in use by the CPU or the process is not taken in terms of the particular page, you can remove the page and put it in the secondary memory. Then we can bring the necessary page to the primary memory, because primary memory is the memory where the system can really operate. Okay, so that is the page replacement algorithm. And let us see an example using this reference string. What is this reference string is, it consists of all the page numbers which is needed in sequence for a particular process to take place. Okay, here that means this is the series. First we need the 7th page, and then 0th page, then first page, second page, 0th page, third page, and this process is at a time of unit. At a unit of time, the particular reference number of pages are needed for the process to be successful or the process to take place. So let us see how this algorithm. There are three algorithms, namely first in first out, least recently used, and optimal page replacement algorithm. These are all the three main algorithms, and there are also many algorithms. We will see only these three algorithms. This can be which is used to solve the page replacement problem. Now let us see the first algorithm, which is then first in first out algorithm. Okay, so you all know that first in first out is the pattern of the queue. So all the processes, all the pages are put in the queue in order to get processed. So likewise, this is one particular queue where the reference string is placed over here, and here we assume that there is only 3 frames in the memory for the particular unit of time. The 3 frames are allotted for this particular process. That's why you can see here 3 blocks are here, 1 2 3 1 2. So 3 blocks, that is the 3 frames are allotted. That means at a unit of time only 3 frames can be inside the memory. Okay, so now let us start with the first string. This is a 7th string, so put it in 7. This we are replacing 1 means that is a page fault. Okay, that means we are swapping the page. Now it is empty, so you are putting the page 1, the 7th page, and then next one we are putting the second page, the 0th page, 70. This is one page fault, and then you are putting the first page of page 1, which is the third in the sequence. So 1, so 701. So 3 page fault. So now the frames are empty. We initialized in order as in the queue. 7 first, 0 second, and 1 is the third. We have filled the frame. Now the frame is full. All the 3 frames are full. So we have to replace some frame to get into the new frame, which is 2 for the time being. So how will you replace? That is based upon this first in first out algorithm. So initially first this 7 came into the queue. So remove this 7 and replace by this 2. So 2 0 1. Next this is one page fault, and now 0 is the next string, but already 0 is inside the frame, so no need to include. So this is not a page fault. Only if you replace between the frame and the page, it is called as an page fault, but there is no replacement, only already it is there, so you just to skip this. And then next you have to enter 3. So how to replace this 3 within this frame? 0 has come earlier, that is after 7 0 has come, so 0 has to be replaced now. So replace this 0 by 3. Now it has 3 has come, and then after that 0 has to be placed now. Now which is the first come, which is the number 1 frame first came initially, so that is long in the queue, so we have to replace that one by the 0th frame. So now 3 frames are filled. Again next series comes as 4. So how to replace? Again repeat the process. 2 have come earlier during this process, so 2 has been replaced, so you remove 2 and you insert 4, so 3 0. And then next frame is 2. How to, next page is 2. How to put this at page 2? So 3 has come little earlier. Okay, among this 3 has come more earlier, it is in the queue, so you have to replace this and you have to put this 2 over here, so 0 is already here. And then next thing is 3. So 4 2, how to replace 3? 0 has come earlier in the queue in this sense, so now 3 is replaced, 0 is replaced by 3, so now it is 4 2 3. And then now 0th frame, how to put the 0th frame? Again you have to check 4 is long in the queue, long already came, first came in this series, so remove this 4 and put 0 2 3 as usual. So now 3 is the next frame, next page, so it is already there, so no page fault. 2 is already there, so no page fault. Now you have to put 1. So in order to put 1, which is to be replaced, 2 has been long in the queue for some time, so replace 2 and put this 1, so 0 1 and 3. Then 2, this is one page fault, and then 2 has to be inserted. How to insert 2? Then again check, 3 has come earlier in the queue, that is first in the queue, so you have to replace this 3 by 2. Now 0 already it is there, no page fault. 1 already there, no page fault. Then 7 has to be inserted. How to insert 7? 0 has come long in the queue, so now replace this 0 by 7, 1 2 is remaining. And then now 0 which has come earlier, 1 is long in the queue, so remove this 1 and put the 0th frame, 0th page in this frame. And then finally we have to insert 1. So how to move? Just 7 and 0 come, we cannot remove, so 2 came first in the queue, so we have to remove this 2 by 1. So now this is how the page is replaced between the pages and the frame. So you can check here 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. So 15 page balls have come. This is achieved by the first in first out algorithm. Let us see the next algorithm, how the scenario changes. So next algorithm is the optimal algorithm. What is optimal algorithm is, just look into for the future strings. If the future string is not needed, you can just replace the future string. So here likewise, here initially it starts 7 1 page fault, 0 has to be inserted, next page fault, then 1 page fault. Now we have to insert 2. So how to insert 2? We have to look for the future string. In the future string which is not in nearby, we check for whether 7 is nearby or 0 is nearby or 1 is nearby. If we keep on checking the string here, 0 and 1 are somewhere here, but 1 is lost in the queue, so you can replace. This will be needed only for after long time, so we can remove this. So we can remove the 7 and replace by 2, so it is 2 0 1. Next one is 0, no page fault because 0 already in the frame. And then 3. So how to insert this 3? Now check for whether which can be removed, whether 2 can be removed, 0 can be removed, or 1 can be removed. We can see here nearby here 0 and 2 are there, only 3 is little bit farther, so we can remove this 3 and we can just we can remove this 1 because 1 is very farther. We can remove this 1 and put this 3. Then again 0, no page fault, then I have to remove 4. So in better you can check for the nearby 3 because the frame size is 3. You can check only for the nearby 3 frames. Yeah, suppose if I want to insert 4, I check whether this, I want to insert 4, so I can check whether I can replace 2 0 or 3. Here in this nearby 2 0, 3 are here, but 2 and 3 are very closer. 0 is farther. So you can remove this 0 for time being. So remove this 0 and replace by the fourth frame. So 2, 4 and 3. Then again 2 is inside, no page fall. 3 is inside, no page fall. Then come to the 0th string. This 0 has to be inserted. Now you have to check whether I can remove 2, 4 or 3. In order to remove this 0, I can check for this 3 frames. Why 3 frames? Because the given problem, the page frame size is 3. So while checking these 3 frames, 3 and 2 are needed immediately. But there is no existence of 4 nearby or already. So what you have to do is you can replace this 4 by this 0. So 2, 0 and 3. 3 already here, no page fall. 2 already here, no page fall. Then 1. So how to remove, how to insert this 1? Again check. Nearby 3, 2, 0, 1 are needed, but 2, 0 is very close. So you cannot remove this 2 and 0 for time being now. You can remove this 3 and so 2, 0, 1. Then again 2, there is no page fall already there in the frame. 0, no page fall already there in the frame. 1, there is no page fall there in the frame. Now coming to the string 7, you can check for whether I can remove this 2, 0 or 1. Checking this 3, I can find out that 0 and 1 are close by, which will be immediately needed, but there is no 2 over here. So I can remove this 2 and put this 7. So 7, 0, 1. For 0, 1 already it is there, no page fall. 1, there is no page fall. So now if I check the page falls, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So only 9 page falls. So when compared to the previous algorithm, previously it was 15 page falls and now it is 9 page fall based upon this optimal algorithm. Let us see one more algorithm, least recently used. What is least recently used is we are just using the past knowledge rather than the future. For optimal, you used the future knowledge, whether it is expected to be used or not. But in the case of LRU algorithm, we are checking for the past knowledge. What is past knowledge is which has come earlier and which is recently used and which is least recently used. Least recently used means just now I have taken the frame, I need it for a little bit later, so I need not use the frame now. Check for the frame which has come and not used for a long time. That is called as an least recently used. So replace the page that has not been used in the most amount of time. Associate the time of the last use with each page. So we can use the timing. Based on the timing, I can replace this pages. Now let us see the example over here. Reference string is the same reference string, the example is taken. So again it starts with here 7 page fall, 0 is entered, page fall, then 1 is entered, page fall. Now I have to remove this, I have to insert this 2. So how to insert this 2? I can remove either 7, 0 or 1. So I have to check 7 has come earlier but not used so far. That means it is least recently used. So I can remove this 2. Insert this 2 by removing 7. So it is 2, 0, 1. Now 0 already there, no page fall. Now I have to check for this 3. In order to put this 3, just now I have used 0, just now I have used 2, but 1 is least recently used. So I can remove this 1 and put this 3 in its place. Then come to the 0th string, it is already there, no page fall. Then come to the 4. To remove this 4, I have to check. Just now I have used 0. Just now I have used 3. So I have used 2 long back. So I can remove this 2 and replace by this 4. So 4, 0, 3. Now 2 has come. So how to insert this 2? I have to remove which is not being used for longer time. So in order to put this 2, I have to check 0 is used, 4 is used recently, 0 is used recently, but 3 is least recently used. Here also you have to check for only 3 frames because 3 is the size. And now replace this 3 and then by 2. Then check for how to insert this 3. I have used 2, I have used 4, so I cannot remove this 2 and 4, so I have to remove this 0 by 3, and then 3, 2 already there, no page fall. In order to replace this 1, I have to 2 is used recently, 3 is used recently, but 0 is least recently used, so replace by 1. 3 2, then 2 no page fault, then 0. For 0 also, how to insert this 0, 1 is used recently, 2 is used recently, 3 is least recently used, then use this 0, and then 1 already there, it is an page fault. Then for 7, how to use, 1 is used recently, 0 is used recently, then you have to replace by 7 by 2. Okay, and then finally it is 107, 0 is there, already 1 is there, no page fault. Now counting here, 1 2 3 4 5 6 7 8 9 10 11 and 12. Now here the page fault is 12. So this is how the page fault varies between the algorithms. In here we have two different variations, least recently used and most recently used. Okay, so this is how this basic algorithms of page replacement works. Hope you understood the concept of this page replacement, and thanks for watching.